Earth has stayed stable for 4.6 billion years because of a delicate balance with the sun. If Earth moved too fast, it would break free and drift into deep space. It would become a rogue planet and eventually die in the cold and darkness. If it were too slow, it would be swallowed by the sun's space-time well and fall into the sun in flames. Only the right speed keeps Earth from escaping or falling in, letting it orbit the sun in peace. So how did it get that perfect speed? The answer is a bit harsh. The universe filtered it out. When the solar system formed, there were countless fragments and asteroids. Those moving too fast escaped. Those too slow fell into the sun. Only the ones with the right speed survived. Earth is one of those survivors. Newton explained this with a thought experiment over 300 years ago. He imagined a cannon on a very tall mountain firing horizontally. If the cannonball is slow, it follows an arc and falls back to the ground. If it's faster, the arc becomes longer. If it reaches 7.9 kilometers per second, its arc matches Earth's curvature. It keeps falling toward Earth, but never hits the ground. Because Earth is round. As it falls, the ground curves away beneath it, so it never catches up, and ends up orbiting Earth. That's the origin of orbital speed. And the same idea explains Earth orbiting the sun. So in a sense, Earth is always falling. Its direction just keeps changing, which forms an elliptical orbit, and it's very stable. Scientists say Earth's orbital eccentricity is only 0.017. That's almost a perfect circle. Earth is like a skilled skater, gliding around the sun for 4.6 billion years, without ever falling. But this stability isn't forever. In fact, Earth is drifting away from the sun by about 1.5 centimeters a year. The reasons are complex, mostly tied to solar mass loss and tidal effects. But don't worry, at that rate, in 100 million years, Earth will only be about 1,500 kilometers farther out. That barely affects its temperature. What really matters is the sun's lifespan. In about 5 billion years, the sun will run out of hydrogen and become a red giant. It will expand to more than 200 times its current size, swallowing Mercury and Venus. Earth might not be swallowed, but it will be scorched into a barren rock. The oceans will evaporate. The atmosphere will vanish, leaving behind a lifeless stone world. Of course, that's 5 billion years away. After all that, there's one more question. Earth is racing through space at 30 kilometers per second, while spinning once every day. At the equator, the spin speed reaches 465 meters per second. So why don't we feel it? The answer is simple. We're moving with Earth, and that motion is constant. Think about riding on a train. When it moves at a steady speed, you can walk around inside without feeling the motion. You only feel it when it speeds up or slows down. Earth is the same. Its rotation and orbit are nearly constant. There's almost no change in acceleration, so we don't feel it. And everything on Earth, air, oceans, mountains, moves along with us. We have no stationary reference point, so the motion is impossible to sense. That's inertia. If you've taken high school physics, you know Newton's first law, the law of inertia. Now let's sum it up. Earth doesn't fall through space for 3 main reasons. First, there is no up or down in space, so the idea of falling down doesn't really apply. Second, that the sun's mass curves the space-time around it. Earth moves within that curve, creating an orbit. Third, Earth has enough sideways speed that as it's pulled toward the sun, it keeps moving sideways, and that creates a stable orbit. This system has run for 4.6 billion years, and it will keep running until the sun burns out its last bit of fuel.